is terminal hot. Buildpacks ready, containers on the spot. From Heroku wisdom to CNB maintainer mode. Time to containerize and hit the road. We're building, we're packing, we're shipping today. Cloud Native Buildpacks in every way. No Docker files, no YAML mess. Just pure automation at its best. At Rawkode Academy. Language stacks and custom configs, CI/CD pipelines, no cheap tricks, real implementations, pitfalls exposed, unfiltered truth from someone who knows. We're building, we're packing, we're shipping today. Cloud Native Buildpacks in every way. No Docker files, no YAML mess, just pure automation at its best. At Rawkode Academy. Questions welcome, performance, deep deployment strategies you can keep. Working session, bring your code. Welcome to the Rawkode mode. We're live, we're learning, we're doing it right. Practical knowledge burning bright. From setup to deploy, we'll show you the way. It's Buildpack time at the Academy. Rawkode Academy. Rawkode Academy. Rawkode Academy. Rawkode Academy.
Hello and welcome back to Rawkode Live at the Rawkode Academy. I'm your host David Flanagan, and today we are continuing Rawkode Live, taking a look at awesome open source projects in the cloud native space. And today we're taking a look at Cloud Native Buildpacks to help simplify your life around building production grade container images. Joining me today, we have Terence Lee from Heroku. Hi Terence, how are you?
Hey, David. Pretty good, you know. Getting halfway through the year, which is kind of crazy to think about, right?
Yeah, I mean, it still feels like we're just kicking off 2025, and yeah, we're already in July, which is just wild to me. But time flies when you're having fun, I guess. So hopefully we're both having fun.
Yeah.
All right. For anyone in the audience who is not familiar with you, we know that you are a co-founder and maintainer of the Cloud Native Buildpack project, but would you like to share a little bit more with the audience?
Yeah, I'm Terrence. I actually I work at Heroku and just passed my 15-year milestone, which feels
Wow.
speaking of time flying, it feels like wild to think about. I don't know what that is in like dog years or whatever in tech. But it feels like a long time. And yeah, I've been working in some form of Buildpacks for most of my time there. So it's we had classic Buildpacks, and now we have Cloud Native Buildpacks. I feel like, you know, some number of years later. So kind of fun to be on that journey that whole time. And yeah, live in Austin, Texas, and it's where we love tacos, where you can have a taco for every meal of the day. And so I think that's like the fun thing about being in Austin, is that it's okay to have it for breakfast, lunch, or dinner. So if people are in town and want to hit me up, happy to take you out for some tacos. Oh,
Yeah,
my
I've been
audio
to.
level too low.
Oh yeah, Eric is saying it's a little bit low. Yeah, you want to, if you can crank that up.
How do
Actually,
sound
I'd
now?
be,
Is that better?
I'll let Eric confirm because you sound okay on my end, so I'll let Eric make sure. Yeah, I've been to Austin and I got taken. Is it Torchy's Tacos? I
Yes,
think
definitely
I
one
got
of the
taken there
chains.
many times. So I definitely love my tacos. But I think in today's, 15 years at a company in 2025 is wild, right? Because people seem to jump around so often. So it's amazing that you've been able to put in so much time there and focus on what I always think is, I don't know if this is a Heroku mission, right? But I'm going to say it because it's what I see from the outside, is making the hard thing simple. And like to do that for 15 years, you must have seen a lot of things and hopefully solved a lot of problems for a lot of people. So I'm assuming Buildpacks is classic and cloud native is, a good part of that story for you over those 15 years. So
Yeah, definitely. It definitely has been a really important thing for me, and yeah, something that is near and dear to my heart after working on it for so long. So happy to be able to come on here and chat about it.
yeah, well, maybe we could try and understand, the history of Buildpacks. What was the need back in the day? Why did this project start around, and why the reboot for the Cloud Native Buildpack project as well?
Yeah, so it started at Heroku. When Heroku started as a company, we were the IDE, and then eventually kind of pivoted to the kind of PaaS side of the business, and really made our name for ourselves in the Ruby on Rails space because that was the only platform and language we supported, right? And so it was Ruby only PaaS. And when I came to join the company, I remember I got the pitch from the CTO, Adam Wiggins, at the time. Like, he wanted Heroku to be a place where you could run anything. So we were trying to make the pivot from kind of being this Ruby only platform to this polyglot platform that could run kind of what from Heroku today, right? Like, I can run Python, I can run JavaScript on top of Node.js, Java, PHP, et cetera, right? And so in order to do that, there's probably a bunch of different ways to think about how you'd architect that solution. But we eventually basically took our build system, which had, all the build stuff with the Ruby specific parts kind of all intermingled, right? And you can imagine if you're going to go through and kind of deal with that, like you could go and add the language specific parts throughout your build system. But I think Adam had the foresight to we should go and extrapolate kind of all the language specific bits right out of that. And that was kind of the start of basically what would eventually become Buildpacks. Was we were looking for a way to kind of make it so your platform could be language agnostic, essentially, right? And kind of have that piece of it. And he always had the vision that he wanted to be an open source thing. And so, we had early polyglot support, adding like one language at a time kind of in the early days. And then a year later, we took the thing that was powering that system and essentially open sourced it as Buildpacks at the time. And we made our Buildpacks open source. I remember spending a bunch of time just like documenting and making it so we weren't ashamed of the code we were putting out in the public. And essentially it meant that the API was public and people could we use it as a way to extend our build pipeline, essentially, right? So like you could, if you wanted to add, we've seen some amazing things, right? Like Elixir on the platform, R, et cetera. And then we also had other platforms pick up this thing. So we had like Cloud Foundry, probably the most famous, right? Where they took our build packs and you could run for a long time just the Heroku build packs on their platform. And, it's kind of an alternative to replacing that part of it in like a Chef or Puppet script where you could use it, Chef and Puppet, for doing other infrastructure stuff, but you don't need it to for the language things. And you could have this kind of centralized way to standardize how essentially like Ruby is built across your entire platform, or Java or whatever, like some language type things. And then we also saw it extend beyond languages as well, right? So people built like a Minecraft build pack. For instance, right? So you take whatever you kind of want and be able to encapsulate like the ability to standardize parts of your build pipeline in that way and kind of have that in a platform. And so we saw people adopt that, and going back to Cloud Foundry, they end up actually forking our API. So we actually end up diverging in some ways where they always supported our build packs, but since they introduced changes, like you could use Heroku build packs on Cloud Foundry, but then Cloud Foundry had Cloud Foundry specific build packs to kind of fit the needs they had. And then we added different things too as kind of Heroku evolved. And so we kind of diverged. And so when Docker came out and kind of help standardize like the ability to have containers and run them locally. Like there weren't great ways to run build packs, and we were still producing proprietary formats for our platforms, right? So for Heroku that was slugs, for Cloud Foundry that was droplets, and someone who wanted to use this like basically was very entrenched in a very specific platform. And I think Docker was showing the ability, like the fact that like people were standardizing around this artifact format of the OCI image eventually, and you could run that with a Docker, with a Podman, push that to a registry, right? And so there was a lot of conversations of like, where does buildpacks, with Dockerfile too, like where does buildpacks kind of fit in this world and ecosystem? And so we really had two goals in mind when we got together with Pitfall at the time, who was kind of running Cloud Foundries. We actually shared a lot of the similar set of problems, being to the big companies kind of betting on build packs of like, where do we take build packs, even though essentially we weren't working together at all at that point, and realized it would just be better if we kind of unified our ecosystems a little more and figure out a way to leverage basic standardization. So that's kind of how Cloud Native Buildpacks got born, right? So with Cloud Native Buildpacks, we want to take all the lessons and things that people love about Buildpacks today, where like as an app developer, I can just git push, right, and get a thing that's running, or CF push, right, and get a working kind of artifact at the end that I can run. But instead of making a proprietary thing, it's going to make an OCI image. So that meant that like you don't have to build all the tooling, right? Like once you have an OCI image, I can Docker run that. I can push that to a registry. That means it can run in Kubernetes. It can run into like whatever container runtime you want, right? And so it allowed us to kind of build on top of existing things instead of us having to build all those things. And having a unified API also meant that like we weren't building, build packs that were, at least on the surface, like incompatible. Like they may be incompatible for other reasons because the details matter, but like at least on the surface you can have an opportunity to kind of have a unified ecosystem across various build pack authors.
Nice. It sounds like the original problem you were solving wasn't really the one that I think that applies today, which is interesting to see that evolution, because Cloud Foundry and Heroku as PaaS providers, you've got to take arbitrary code and be able to run it in a secure fashion, right? So like Buildpacks solve that platform thing. Whereas what I see today is that people just want to simplify the chaos that is building, small, minimal, secure Docker images or container images, I guess I should say, to run them in their Kubernetes clusters. So it's interesting to see that. But it makes sense, right? Because Heroku, they still offer this, and it was new at the time, but that whole get push to deploy thing just didn't exist. And that brought around all these different challenges. You weren't asking customers, give us a container artifact, because when Heroku started, there probably wasn't such a thing at the time. But it's just interesting how that application of the technology has evolved to where it is today. And also, I'll add that I've been a consultant for a long time, and my first article I wrote was in 2015 about how not to be the person on your team who's shipping the 1, 2, 3 gig plus Docker container image sizes. And it's funny that even though today you would assume this is better, people still really struggle with Docker files because they're so simple to get started, but really difficult to get right from a CI/CD caching perspective, and trying not to bust that cache, but at the same time making sure you got the tools that you need for production, for debugging, but not shipping everything in the kitchen sink. And I feel that build packs today are still super relevant in this regard, because there are a lot of people that just don't care, and they just want something that works, is performing, and follows best practices. And I feel like Cloud Native Buildpacks they just slot perfectly into that space. And I'm really excited to show people how to get started with that today as well.
Yeah, I guess on that point, I feel like a lot has changed in the last number of years too, right? Like I think the target audience you're talking about, right? It's like, I'm an app developer, I want to build an application. And I think like what's required today, without stuff like build packs, with things like Docker files, that you probably have like this one person on your team that knows how to do it, right? That built that Docker file, that did it. And it essentially, it's like, I think back in the day, right? It was, rewind 10 plus years ago, like you could just be your full stack developer that knew, Spring Boot or whatever, plus your business logic, and that was enough. And I feel like more and more these days, like you're pulling more stuff in of what it means to be a software developer, right? Like not even including the whole AI buzz and kind of all the stuff that's coming with that. But yeah, so just like, how do I containerize my app? How do I maintain that? How do I, if like I'm building against Kubernetes cluster, do I have to know enough about Kubernetes to operate that thing? So you're just getting more and more stuff kind of being pulled in of what it means to be an app developer today.
Yeah, I call this cloud native fatigue, right? We've made everybody adopt microservices, and like your code will be so simple, but then you've got, oh, wait, hold on, we're pushing all this complexity somewhere, and it's going to the infrastructure layer. And like you have to learn where the service mesh is, and you have to learn what protobus and gRPC is, and you have to learn what observability is and Kubernetes. And yeah, it's also, you're right, it's never been as difficult to be a software developer. But now we get this AI trend, and it's like, is that the skill that ends all the other skills? Do we all just sit in front of Cloud Code and say, deploy my app? Who knows? That's not the topic for today, though. But definitely interesting times ahead. YMO, let us know if the audio is okay. I think it has been tweaked. I'm hoping that it's better. So just give us a thumbs up or a thumbs down in the comments. All right. Thank you so much for the history on Buildpacks. It's great just to get that flavor and context and understand the evolution over time as well. So last question before we get hands-on and actually show people how to get started. Like, what is the state of Buildpacks today, right? It's obviously a new version, it's collaboration, it's a CNCF project, it's evolving. Like, where are we today for people to adopt Buildpacks?
Yeah, I guess like when you mean that, I can start talking, you can tell me if I'm going along the right lines. Yeah, it's a CNCF project. It started, I want to say like 6 years ago, which feels old too. Feels like just yesterday when we kind of kicked it off and joined the CNCF, the sandbox. But we're in an incubation project now. We're trying to go through the graduation process. And for those who are less familiar with the CNCF stuff, there's sandbox, incubation, kind of graduation, right? I think Kubernetes was an incubation project for a long, long time as well. And it's used in production, right? Like we have it, I know, on our end at both Salesforce and Heroku. And for those who don't know, Heroku's owned by Salesforce. And, you know, on like the kind of, I guess it's now Broadcom, but Pivotal VMware Broadcom, it's part of like the Tanzu product over there, the Cloud Native Buildpacks stuff. And so there's a whole open source side. We'll probably get into the different builders and Buildpack projects out there in the hands-on, but there's a Paketo project that is basically associated with Tanzu that they help maintain over there. Like a year ago, not this past KubeCon EU, but the one before, the one in Paris, Bloomberg basically talked about how they use Cloud Native Buildpacks to power their AI ML platform internally. So,
nice.
You know, none of it's like open source or public necessarily, but they do extensively use kind of CNBs to help, or Cloud Native Buildpacks to essentially help with data scientists essentially. So they don't have to write and maintain Docker files because that's not what they're there to do, right? So it helps them kind of meet the strong financial security requirements that are required to be a financial institution like a Bloomberg, but have data scientists who don't have to kind of pull in those concerns we're talking about, right? And if you want to learn more, I definitely not the expert there. That was a keynote session, and those talks are up kind of for the Paris KubeCon from 2023. And yeah, Google Cloud Run as well is probably the other big one, right? Where it's like they are using Buildpacks, they're open source and public, and you can definitely use those Buildpacks as well.
Nice. Yeah, I think you answered that perfectly. I think anyone who is unsure whether there's enough confidence in the project to adopt it in production, that is now well and truly squashed. Like, yes, these companies are doing it. You can do it too. So with that, I think we will move over to screen share and let's show people how to get started. So here is the Buildpacks website. You can find it at buildpacks.io. And we'll zoom in. We're just going to go straight to the getting started guide like we always do on Rawkode Live. Over here, I have a CNB directory. Because I run Next, I make things hard for myself, so you can ignore everything that is here. It's just Next files so that I have the pack CLI available, which I'm hoping is the only thing I'm going to need for today's session. So. Now, I think the thing worth noting from the getting started docs page here is that there's 3 different personas. So maybe Terence could just take a moment to explain the 3 different applications for build packs and how people may want to consume them. And then I think we'll dive straight in and take a look at the app developers idea.
Yeah, I think, since buildpacks kind of sit in this middle ground somewhere of connecting essentially people who run the platform, that's what we talk about for platform operators, and then kind of app developers as well, are the customers of that platform, right? And so that's kind of the dissection there. And then I think because buildpacks are trying to do standardization, we have this. I think that doesn't really exist in a lot of companies except a handful of them like Heroku, where we have like our languages team, where it's like you have people who essentially take on all this responsibility for the company of basically writing build packs. And so there's build pack authors. And I think probably in a lot of companies, you would imagine you're probably not going to go author a bunch of build packs, but you may author a few of them. And a lot of them would probably fit in a platform team or something, right?
Nice. All right, let's click on tutorials. We're going to build our first application with a build pack. So the first thing we need to do is select a builder. So let's run pack builder suggest and see what we get back.
Yeah, and I guess while you're running this, I can talk about what a builder is, if that's helpful.
Of course, yeah, go for it.
Yeah, so builders are essentially they are ultimately an OCI image, but it's a way to encapsulate essentially a set of build packs, so you don't have to go and download ones on the internet. You can during the build process, as I think we'll go through in the tutorial. But you can kind of see like the build packs I talked about, like Paketo, there's Heroku, the Google ones, right? And so these are essentially, we don't actually make any build packs in-house. It's a spec project as part of the upstream project, but essentially there's vendors out there who essentially have open source build packs that they maintain these builders, and it is essentially these build packs on top of the base image that they maintain, right? And so depending on which one you pull, you're going to get that base image that they run on, as well as the build packs associated with that vendor.
Is there one that, for the new person to build packs who just wants to get started right away? I mean, this list is in alphabetical order, right? There's not any kind of preference here guided to people, but is there one that you find will allow people to be more successful more often versus other ones?
I mean, I'm biased because I work at Heroku, so I'm most familiar with the Heroku ones, but we definitely have a bunch of people who use the Paketo ones. I think the Google ones are pretty good. I definitely have less experience with those, but I think that is very much geared towards probably like if you're going to run on kind of Google Cloud Run or GCP, like it's very much geared towards that, right?
Yeah, I think the thing that jumps out to me most here is that the Heroku one uses a more recent version of Ubuntu, but also mentions explicit ARM64 support. So I guess that's important for many people, but especially, I guess, if you're running on a Mac, you might need that right off the bat. So.
Well, Mac supports have pretty good support, I think, historically because of Docker, right? Like I think we've been running AMD64 stuff on Mac for a long time, so I actually think all these will work fine on a Mac. But yes, there's some nice performance considerations when you can build it natively on ARM, for sure.
Yeah. I mean, I don't have a Mac, so I was also speculating, so it's good to know. All right, so we are going to, for this guy, we're going to use the CNBs sample builder noble, which I'm assuming is a Debian image, which is not listed as suggested because it's just a sample. Okay. So it's told me that I've decided what builder to use, but it hasn't told me. All right. Okay. So scrolling down, when we do a pack build, which is to build our application, we provide -- builder, and that tells it which builder to use as part of that.
Yes.
All right. So I will clone our sample directory. So is this just some sample applications? Yeah. Oh, and sample builders and sample build.
Yeah, this is just our sample repo that has, so you can just point someone to a single repo and be like, if you want to look at some sample builders, build packs, apps, base images, etc., like you can go to this one directory to kind of find it, which makes it convenient.
All right, awesome. So we've got a choice of ASP, Bash, Batch, Java, Kotlin, or Ruby. No Rust. I'm very disappointed. Let's stick it. I mean, you can't go wrong with a simple Bash script, right? So.
Yeah.
All right. So I will copy this, and I'm going to change it. So let's just call this Rawkode demo 1. I'm assuming this is just the name of the output container
This is the
image.
name of the image, and by default we're using, I think, Docker under the hood, but you can use Podman as well.
Okay, I had both available, so that's good. So I'm building Rawkode demo 1. I've set the path to be my current directory, and I'm telling it to use the sample builder like so.
Yeah. Yeah, if you're just using the current directory, you don't have to specify path.
Nice.
In the future, it kind of assumes path is a way to kind of override. One thing to note here, I guess you probably don't have the sample builder at all, but it does try to pull in the new version of the image. So one of the things that happens in Docker is if it exists, it won't try. And this is definitely a thing that I think comes from the classic buildpack side, is like we always want people to be using the latest and greatest most of the time. So you get the security updates, etc., on each fresh build.
Yeah, I'm assuming we're using a dynamic tag here on this container image, but I'm assuming if I wanted to use some sort of content addressable SHA, that would just work anyway, right? So.
Yeah, 100%. So if you wanted to like hard code and not have it be that way, you can definitely do it that way.
All right. Well, I mean, it looks like it's done already. So looking at the output here, we pulled down the builder. We've got some very clear stages or phases that we're going through here. One is an analyzer, where it's looking for some sort of pre-existing image. It then detects, not sure what we're storing is. We then have a build stage and an export stage. Assuming if I run docker image ls, we will see our Rawkode demo 1 here. I also assume that I can run this. I have no idea what this does because I didn't even look at the code before we went for it. So let's just latest, and we get some ASCII art saying buildpacks. Nice.
Yep.
Maybe you could take a moment then just to kind of give us the kind of deeper dive into what actually happened when we ran our pack build command.
Yeah, if you want to scroll up to the kind of output there. So the first thing, so buildpacks are actually, when we get to the buildpack authoring, you'll see there are really just two binaries plus some metadata, and that's going to be detect and build. And so you can kind of ignore analyze and restoring because they're used on basically subsequent builds. So if you're doing a second or a third build, that's where they kind of come into effect. And they essentially don't do anything on a first build because nothing exists for it to kind of look at, right, from the previous build. And so the first thing that's going to happen, this is pretty simple in the sense that it is just a bash script, but you essentially can have, we're going to go through and buildpacks are going to figure out if they should run at all, right? And it's also the way they can do some cross communication as well. But in this case, it is just a bash buildpack, so only the bash buildpack is the one being detected. But that builder probably has all the other languages that you saw in that sample guide as part of it, and we can pop up and open a builder as well to kind of go through and look at that. And so once you've decided the build pack plan, assuming you can find a build pack that needs to run, it'll go through and then execute them according to the build pack plan. Obviously very simple in our case, we only have the one build pack. And then this is essentially where the meat and potatoes is during the building. It's going to go and run and execute whatever the build pack author has decided it needs to do. And this is where you get a lot of the flexibility. You're not really seeing that here for such a simple example. But one of the things that is important to note is we aren't writing a Docker file or anything under the hood and magically translating it. We're constructing the OCI image essentially by hand as part of the lifecycle export. So it means we're also not beholden to any of the like layering, caching kind of constraints or automatic things that Docker files do as well. So the buildpack author actually has a lot more control over how you cache a layer, whether a layer should be cached. And so it can work around certain things like needing a multi-stage build, for instance, right? When we go down into kind of the export, you can see all the layers that get exported. In this case, it doesn't look like it actually creates any specific layer for the bash build pack, but essentially a build pack, maybe if we go and run like another example, you'll see it will create essentially other layers for those build packs.
Let me copy this again so I can modify it. So I guess the Kotlin one might be a better example.
Yes, Eric, to answer your question, is the build pack sample on GitHub. That is what we're working out of.
All right, so just while that's building then, you said about layering and caching and the fact that you're not using, Docker files, etc. So that raised a couple of questions in my head. The first one being, if I'm running this in a CI/CD environment, do I still need to do like Docker dined in order to be able to do this? Because I'm using Docker locally, but I don't know if that is still something that would be needed in CI/CD. Sorry, on you go. Answer that one first.
Yeah, I mean, to answer your question, it does use containers. So like we don't use Dockerfile, but we sort of are using a container system, right? So that's why I was saying you can use a Docker or a Podman. So if you are doing in CI/CD, whatever you need to do to actually like get a Docker build to run, you probably also need to do that. Conveniently, like a lot of the public vendors out there have native support for a Docker kind of system. So oftentimes you can just have pack in your CC, and that's how we see a lot of people actually implement it kind of in-house in their platform, is like they just leverage because it's such mainstay, right? Like these days to leverage Docker. So a lot of kind of systems already have that in there where you aren't kind of expected to kind of Docker and Docker.
Mm-hmm. Cool. And because there's no Docker file, I'm curious, how is the cache performance affected then? If I were to run this build again, would it just say, oh, we already have the latest and greatest image, or would it run through the entire builder process again?
So it goes through and it runs through the entire build process. And this is where, as a build pack author, you get a lot of freedom and flexibility. So like I was talking about, so build packs can actually specify essentially how it works under the hood is that as a build pack author, you get basically there's a layers directory where you can write layers to. And in this case, I think the bash build pack just doesn't, because it's so simple, right? Like it doesn't do anything. It doesn't need to do stuff. And you'll see in here, right? Like the difference in this export is you have this samples Kotlin, Gradle, JDK. And before, like we just started at the launch SBOM in the bash one. And so in this build pack, it's essentially creating a JDK layer, and it's putting the JDK in there. And so that means that, so for every layer, you get to decide kind of a handful of things. You can decide if it should be in the launch image. And so this is the launch image, essentially, is like the final image that gets output. You can decide if it should be part of the build output, like the build image. And so the build image is basically used only at build time. And so that's a way to store stuff. Like if we're doing a thing in Java, right, that might be like the M2 cache, or like kind of the repository of stuff where you probably want to cache that so you don't download it fresh every time, but you don't actually want to bloat your image with that, right? So that's where you would create a layer. And so you basically just create a folder and you can set a layer metadata, and you get to set these flags. There's booleans essentially. And cache is another layer where you get to say this thing should be cached. And that means like when we do the second build, that's when you see that restore phase. It's going to kind of pull that kind of layer back. And then you can also tie, essentially, you get access to a table where you can set key value stuff on it. So you might want to, for instance, store like the JDK version, because the question you're just asking, right? It's like, if I change the version of my JDK, I probably want to throw that layer away, right? But if you're doing something like, let's say you have a JavaScript, image with a Node.js build pack, I'm going to run an npm yarn or one of these dependency managers. Maybe what you store in there is the checksum of the lock file, right? So like if the lock file changes, like maybe I throw it away or not, but like you actually get the benefit that you can do something potentially even better, is that it's not a 1 or 0. Like you can choose to pull it back, and if the checksum matches, you can skip the entire step, but you can also choose to like not skip the entire step, keep the contents of that layer, and just rerun npm install. So like I don't have to reinstall the new things. I can just go and install like the one, or I guess in Node's case, maybe like the 10 modules that get added for my one dependency, right? And so you get that flexibility, but that is controlled by the buildpack author, if that makes sense.
Yeah, I mean, it makes perfect sense, right? The buildpack author is the person who hopefully has the expertise working with this ecosystem, language, runtime, etc. You're no longer putting the onus on the developer, who may also do that stuff, right, but may not be familiar with building container images to the point where like they don't need to know you have to mount a package.lock and a package.json, run an npm install so that it's cached, and then bring it on your source code. This now becomes the responsibility of someone who is building the build packs for consumption, which makes perfect sense, right? So
I think the benefit, like you're starting to see, is like it allows you to extrapolate and pull all this kind of very kind of specific knowledge about like that person is really a like subject matter expert in that ecosystem of how it should work, because you know one minor change might be the other thing you might want to store in that Node example is like the ABI of the Node runtime, right? Because if that does change, you probably actually do want to blow that entire cache away, right? Because now you need to recompile all those native extensions because the ABI has changed. And so that's the level of like kind of stuff where you want to be able to have that knowledge in like a very small part of the company and have everyone else kind of be able to get that productivity boost from that.
Cool. Awesome. Now, one thing I did notice here is we did a pack build. We provided a builder, but we didn't provide any build packs. So the build packs are shipped with the builder image. Is that correct?
Yes, that's correct. If you want to, we can go into
inside one
repo and kind of just look at that, or you could just I don't know if there might be bash on this thing for you to kind of look. I guess there is. I think you're gonna wanna. I forget how this is laid out. The actual image itself is maybe the CNB repo or the directory. Yeah, and so you can kind of see the build packs, and those are mounted as layers, and so you can kind of see all these ones that are kind of packed in.
All right, there we go. We found a build pack, a Kotlin one.
Yep. And so if you own a bin, you can see the build and detect that I was just mentioning. Those are just, I'm sure, just bash files.
Cool. So a build pack then is shipped with the builder. The builder can have any arbitrary number of these. They're referenceable by name. Not that it really matters, because what happens here is they have a bin directory, which just has a bash script which works out whether this build pack can build your application. So for Kotlin, it's looking for the Gradle wrapper, and that's it, right?
Yep. Yeah. The whole dependencies plan thing here is a way that you can actually essentially coordinate between other build packs for that composability. So it basically is saying that it's providing JDK and requires one. That's what this build pack does. But you can imagine, for instance, a Kotlin build pack that is made up of multiple build packs, right? Of like, there's a JDK specific one, and then one that actually runs Gradle, right? And et cetera, right? And so like a good use case for this might be you're in a company and I think this is very common. It's like they pay for support for this version of said runtime, Java being a great example of this, where like they pay for it. And so it means that like you can go use the Paketo build packs. Like we see this all the time in companies where like they're going to go use the Paketo build packs because how they actually use Maven isn't innovative in a company, right? Like they don't want to go and build their own Maven build pack. But what they do need to do is like they care about the version of Java they're running. And so what they're going to do is they're going to build their own version of their JDK build pack, plug that into the system, build their own builder that has the build packs they need, but then not rebuild things that they don't have to basically care about, right? But they want to use. And so I think that's where you kind of see that composability, if that makes sense.
Okay, so they would build their own build pack that had their version of the Java runtime, but they would have some sort of require statement that says, I require some sort of Maven, and then that would be composed by the builder.
Yep.
Right.
Yep.
Okay. All right. Got it. Now, just out of curiosity, in the CNB directory, we have lifecycle, build config extensions. I mean, is there anything of interest here that we should kind of cover, or should we get back on track with the tutorial?
If you can open, I think it's the run Toml. So lifecycle is, I guess, like just to answer that part of it, is essentially the buildpack lifecycle runner. And so it's the thing that actually executes the phases of that you saw during pack build. And it's also used when you ran your Docker run, the launcher is used to essentially set up the environment. So like if your build pack essentially sets environment variables and things like that, it knows how to essentially do that and then kind of essentially exec fee the kind of process. And so it consumes as it becomes the parent, right? In this case, I believe, yeah, so the run Toml, so you'll notice that it points to another image in here. And so there used to be a concept that came from Heroku and Cloud Foundry called Stack, but I think Stack is just not a thing really in the Cloud Native ecosystem. So the stack.toml is a deprecated thing that's there for compatibility reasons for kind of the older kind of earlier days. But essentially, buildpacks have this concept of a build image and a run image that you want to essentially have, right? Where it's like you have your dev dependencies in your build image, your run image probably doesn't have them, right? You just need the libraries, the SO files rather. And so it allows you to have a smaller run image, right? Like that's this concept that exists. And so the reason you don't have the build image here is because the builder is actually built on top of the build image. So this is the build image is essentially build pack metadata, build pack specific things, the build packs you want to have in there, and then it all sits on top of the build image. And then when you run your pack build, it goes and builds all this stuff, and then essentially when it creates the image, it puts it on top of this image that you have here. And so that's how it knows, what the run image is to actually like build the entire image for that.
Nice. All right. Let's drop out of this.
Yes.
One last thing, and then we'll continue on. So we ran builder suggest. We got this list of curated builders that we could use. Now, let's assume I'm watching this, and none of these tick the boxes that I'm looking for. How do people find other builders, or is there a primary option, build their own, or is there somewhere they can go and find more build pack builders?
That's a good question. We do have a build pack registry, but I don't recall if we added builders into there or not. I know there was a discussion of doing it, but I don't know if we actually did that.
So is that on Artifact Hub, or is it somewhere else?
No, they're just registry.buildpacks.io. It doesn't look like we added builders to the build pack registry. I think it's just buildpacks.
Okay, so this is where someone can go and find build packs for, if I search for Rust, right? Ta-da, go. Got it. Cool, I like that. Okay, let's get back on it. So we have taken one of the sample applications. We've now built 2 build packs. We ran it. It worked. Nice and simple. So we've kind of covered that default persona there, where if you just want to work and focus on shipping the code for your product, for your company, you can now come and use build packs to get started there. So I guess we've got 2 different options that we can go down the fork. The road now, the fork and the road now. We could go and take a look at putting together a custom builder, or we could take a look at building a build pack. Do you have a preference? If anyone in the audience does, feel free to throw something into the chat now. Otherwise, Terence and I will roll the dice and pick a path. I should have said that a few minutes ago before, going and looking
Before
at
we got to the pods moment.
Yeah.
We could go do if there isn't a preference in the community, we could do the builder one, probably because it's quicker to start, and then kind of circle back to build pack author.
Okay, so where's the builder one?
I'm sure it's under, hopefully it's under platform operators.
Is this it?
This just explains kind of life cycle and probably how to operate and run stuff. Yeah, this is explaining a lot about essentially build packs. I think this orchestrate and build with CNB is explaining a lot of like, I'm going to run a platform. Let me tell you what it means to maintain and run a platform for build packs.
Got it.
In the how-to section, does it have more tutorial things? Create a builder. There we go.
Ah, yeah. Nice. All right. So create a build base image. This one? Or put it all together?
So create a build image and run image. These are like, if you can just click on the learn more, and this is essentially, you'll notice like we don't hate on Docker files. I think they have good use cases, but I think the benefits of build packs is it's a much more targeted, and so we can make certain assumptions that Docker file cannot, right? And so I think Docker file is great for building these kind of base images. And so this is essentially just showing you what it looks like to, it looks like anything else, except the only kind of additions are going to be kind of that stuff on below the app get, right? Where you need to set a user, and then you need to essentially set group stuff. And then the interesting to note is that user line means that none of these build packs are actually running as root. So that does limit what you can do. And then you just set essentially these labels. And so you can imagine if you had a base image you want to build, like you can literally replace all the lines above the, I guess, like set required CNB use information with your own thing. And that gets you a working base image.
Okay. So, I mean, a builder is just a container image where I stuff it full of the things that I need to build an image.
Yep. So this is going to be the base image that we're going to use to then build the builder on top of.
All right. So if we scroll down, no. Okay, that's the base. So, and the run one is just the runtime one.
Yeah, exactly. So the runtime one is going to be very similar, except it's going to be specific to. You could use the same image if you wanted to be honest, right? Like, but yes, the runtime image is going to be similar with other metadata for that. And then putting it all together is how we actually create the builder.
All right, so we need a builder.toml where we provide. All right, so we can have a bunch of build packs that we want to. So we don't actually need to construct that image like manually as a Docker file, right? That we're just using the Docker file for the base build, the base run.
Yep.
And then
and
the
so
builder.toml
has a command that helps you basically put it all together and get the new image. And so this builder.toml file is how you construct the image. And so that layout you saw in that image is created from pack builder create using this kind of input there. So the top, you essentially put in the different build packs you want and the paths. And then the bottom with the order is going to be the detecting groups. So like in our example, we had a thing for bash. So it probably, if you go to the samples repo and probably open the builders repo that you're using, we can kind of take a look, right? So that builder, we looked at Noble, right? And so that builder.toml, you can see like it points into its internal repo because they don't have to be on the internet. You just have to have some type of valid build pack somewhere. And we are using, I guess, one from a Docker kind of image as well. Essentially you're seeing, right? Like these are the different groups that we want to have, but you could imagine a group can have multiple build packs in them, right? So in that example I gave of the Java and Maven, like thing for that company, you would see kind of a bunch of different groups of build packs in a group. And essentially the build pack, when it does the detect, is going to go through each of these groups to try to detect the build packs that should run. And it will use the first one that essentially passes.
Cool. Then looks like we have the build and run images and then the architecture support at the bottom.
Yep.
Nice.
Yep. And then I think the guide tells you just run pack builder create, I believe, or some incantation like that. And it goes through and essentially it's pretty fast because it's not really creating, like it's not running the expensive stuff from Docker build, right? Like it is really putting together a image where it has all the kind of things already.
All right, let me ask the superficial question then. So
Yes.
why Toml?
That was probably a me thing. I came from the Rust community a little bit and Ruby, and JSON was in there in the consideration, but I wanted comments. And then I think with YAML, I found the spec was just super complicated. And I do know the Cloud Native community. We get this actually all the time, so it's not super, it's not that superficial, but like, I like to choose the color of the shed I paint, I guess. But I think for us, it just made it easier for us to kind of just like add things and kind of append stuff too. And so we kind of picked Toml for readability, essentially.
Cool. I was just curious. I mean, I'm also a Rust developer, and my biggest pet peeve there is Toml. Just because of these nested arrays, I think it's just a syntax that isn't familiar to people. And then that's not the point. So nice. Okay. So it's just a Toml file. You provide the base and then you provide your buildpacks. Nice and simple. I don't think we need to run through that. I think, it's pretty simple. It's right there. There is a lot of documentation on the buildpacks website for anyone who does want to go into that. So feel free to go and check that out. Maybe we should dive straight over to then, well, at some point I'm going to have to put together my own build pack. So are we happy to do this? Will we try and do it for Rust? Or is that going to, am I making it hard? Is that hard mode?
I mean, if you want to, we could try and see how far we get. But yeah, I mean, maybe you want to click through kind of the things and we can kind of go for it. But yeah, the builder ones I think are pretty simple, but it's a question we get fairly commonly at the booth and stuff, is like people can't use, like some vendors, even if you trust those companies, like your security team's not going to prove it. So I think the builder exercise is a pretty good one to kind of walk through.
Well, I mean, you're probably you're very close to the buildpack community, right? And you're at conferences, you're speaking to people that are adopting it. Like I'm very curious, like out of 10 people that are using buildpacks, how many of them are using off-the-shelf buildpacks versus how many are building their own? Like, is it safe to say, no matter what your language is, there's a buildpack out there, or is it, at some point you will have to do this? I'm curious.
I think most people start with using stuff off the shelf and then figure out where the gaps are of what they need, and then get into building their own, because it is a more advanced thing, right? Like I think the benefit, like you said, of Docker files early on was it's so easy to get started. I think like people can get through, and it doesn't mean it works how you want, but you can get a thing that's functioning somewhere to some degree. And I think build packs are definitely harder, right? Like there's more abstractions, but the constraints and abstractions allow you to do a lot of cool things, but that comes with having to learn more concepts, right? Like the layering we were just talking about, that was explaining. I spent like 5 minutes talking about it, right? And you don't have to really understand how caching works in Dockerfile, and I think that's the beauty of it. So a lot of people, I think, like I would recommend for most people getting started to kind of, I guess, get to the question is like, I would just take one of the builders and see if you can build your app and kind of start there. And then I think as you get more serious, you kind of figure out probably the requirements that you have either for yourself or for the business. Like I think if you're a small company or like an individual developer, you probably don't care that much about, because you don't have teams that you're relying on that are like building your base image, building those things. So you don't have those constraints, and you can probably get away with just like using a Heroku or Paketo builder for the most part. And then I think for a company, you start there, but then when you have to go beyond the POC, like I think that's when you have to start exploring those things. And then that's where I think you might get into building your own builder, building those base images, seeing if the stuff you're using actually works on the base image you're picking, right? And then kind of going that way.
So going with my Rust idea, right? We're looking at the suggest list. There's nothing here that tells me I'm build a Rust application. So assuming I decide that I'm assuming there's some sort of command here to create new. So I can do a buildpack new, and I'll look at the flags in a minute. Do I need a builder at this point if I have my own build pack, or can I still use these existing builders?
Oh, you 100% can use an existing builder.
Okay.
I mean, one of the things I guess we didn't look at as an app developer is that even without creating a new build pack, let's say there was a build pack you found on the registry, right, that you want to use. You can, when you run pack build, run -- build pack and pass it in. So if you click like, that Rust build packet, that command there. So when you run pack build, you can just use that, and it will essentially create an ephemeral builder that will add it in and allow you to build it at build time.
So it doesn't use one of the suggested ones. It just makes one up.
Yeah, you're essentially saying like, don't auto detect this thing. Just use this thing, right? Do you need to like remix your environment?
Yeah, I do. I'm not in my next.
We're going through this rabbit hole.
All right. Devenv is very nice in that I can just say languages Rust enable. Do you use Nix?
I do not. I've not kind of jumped in yet.
Yeah, it's a world of hurt. I don't recommend it. I mean, it's got its perks, but
yeah, I feel like everyone who uses Nix, like it's like a love-hate relationship of like you hate that there isn't something better, but you can't give it up.
From my perspective, and I don't want us to digress too much, is that I think from a declarative everything as code point of view, it is fantastic. Where I differ is that for most things, I don't really need reproducible builds. I just want that declarative machine. Like I love that I can wipe my desktop or my laptop and in half an hour have everything right back the exact way it was because I have everything codified. I love that. I'm not into the whole hermetic thing. I get the value for shipping stuff to production, but sometimes it's a bit of a pain. So now we have Rust up, so I should be able to do cargo in it. We now have a Rust application, and I can hopefully do a cargo build. Okay. So with that, then we can use the image that we pulled.
Yeah, since you don't have a default builder, you're also gonna have to specify one.
All right. Okay. So I have to provide a default builder.
Or you can just pass one on -- builder, right? Like if you're using Paketo build pack, it might just make sense to just pull in the Paketo builder jammy full. I have no idea what Rust needs, so go for the safer, just pull the things in.
All right. Okay. So when I said it says hard mode, building the build pack is the easy part, but making sure the builder has what we need might be the difficult part. Is that?
Well, I think that's where when we were going through that exercise, right? Like you can just pull in, like whatever, right? But yeah, like any build pack that you're running on, that's when I was saying like we start from a layer of at least it's potentially compatible. Is like obviously if you're building build packs and like you have stuff where like you depend on the thing, right? Like you can't just pull it into your builder because the build pack has a contract with the base image, right?
Eric is shocked at how many layers. Although this image was jammy full. This
is jammy full. You probably like. I suspect you actually could get away with a significantly smaller image here, but the jammy full I think is really built for I think like interpreted languages that require a lot of things at runtime. I think if you scroll up to the whatever suggests it had stuff for like Go and Java and stuff, right? Where it's like, oh, like tiny, like you don't really need a lot of things at runtime to run a fully compiled Java or Go app because they, even more than Rust, abstract away so much of the OS. And don't depend
hopefully it's not going to be too much longer. Yeah, there we go. It seems to be getting there. So as long as there's not any gigantic layers at the bottom, we should be good.
Yeah.
Nice. Okay.
And this is why for demos you may want to do the like there is a like if present kind of flag. And so in demos, like at our KubeCons and stuff, you don't want to do this on public Wi-Fi to check every time. Even if there is a new image, you probably don't want it for the demo because you're not building anything for production, but like it allows you to kind of skip through this part. But you can tell this is unscripted.
Yeah, I mean, I'm assuming also I could just do like a Docker image pull in advance for a lot of these.
Oh,
right?
yeah. This is just doing the pull, right? Because the output looks very familiar.
All right, so it's now pulling life cycle stuff. I'm assuming it's almost
I think
there.
it just pulled it, right?
Yeah.
Yeah.
Don't know what it's doing now though.
I think it's saying it's using the untrusted flow. I don't really know why.
Oh, it failed. Max depth exceeded.
That's a Docker error.
Oh, we can try it one more time.
Sorry, I feel like I'm not setting you on a path of success. I don't use the Paketo builders super often. I'm not super familiar with.
I'll tell you what. Well, that does that.
I think that's probably because it maybe has too many layers. I actually don't know. I don't know what the max depth thing is.
I'm just going to pull the Heroku one in the background, and we'll let this. It may just fail again, but even if we can't use that builder or the remote one, it's fine. We can always still put together a build pack and show the detect script and the build script, right?
Yeah, so, like I mean, and one of the things we could try just to get something running is you could just try the sample builder that we have locally and try running that build pack and see.
Can't remember what that was called. Was it build pack sample? No, I'm making that up now, right?
Buildpacks / sample noble, I think. I don't use the sample builder very much, so this is also me kind of going off of memory here.
Yeah, all right. Docker image LS. Oh, well, the Heroku one has now pulled. So we had the sample builder.
Yeah.
So sample builder noble. So what is that warning about then? The builder is trusted using the untrusted 5 phases. Like what is that telling me?
Yeah, so we're seeing definitely like some linking issues here on the Rust side, but it is executing.
Will it respect my Docker ignore if I tell it to ignore that directory?
Which directory?
Well, it's trying to pull in my devenv files.
Oh. I think in Project Toml you can set an ignore. It might respect Docker ignore. We could try it.
Yeah. No. All right, we got here before. Okay. So we'll need to work that one out. But let's just focus on what we want to show, which is how to create a build pack. And then if we can get it working at the end, that's fantastic, but no pressure.
Okay.
So to do a new build pack not build, we need to just give it an ID. Okay. So we can call this Rawkode Rust build pack. Excuse me. And we get this directory. So in the build pack Toml, you said we may be able to do an ignore on that directory, so we can definitely look at that. And we have the bin directory that we've seen with the previous build pack, which is the ability to do detect and build. So if we use VS Code, we can just work on a very simple detect script. So I'm assuming this default one of exit 0 means always detect. And if we exit
like
with an
when
error,
when you have a successful exit, it means the detect has passed, right? And if you want to not, you don't. Exactly.
All right. I mean, Copilot is just going to jump in and do this for us, right? So if we find I'm assuming that maybe don't need that, and if we have a cargo.toml, then we can say that yes, detected a Rust application, right?
Yep.
Okay. And then we have the build. So here we got layers dir, emp dir, plan path. You want to provide a bit of context on what these are?
Yeah, so the layers dir is the directory I was kind of talking about before, where so you have the workspace directory, which is where the current working directory is. So like the current working directory where you're at when you get in is the where you can see the code, right? Like you can see your cargo toml, your source directory, etc. And so that is global across all the build packs in the sense that anything you change and mutate in that directory is going to change and mutate in the final image, right? Because that gets packaged up. And usually that defaults to /workspace. Layers directory is going to be specific to your directory. So usually the layers directory is /layers on the file system, and then it'll be /layers and then your build pack. So in this case, whatever the Rawkode Rust build pack, plus probably some version number. And then anything you put in that directory is going to be, you're going to essentially, you create a new directory per layer you want to create. So you can create as many layers as you want. And then, so like, for instance, we could create a like Rust up directory if we were installing Rust up, right? We could create, so you can imagine like you get to architect and design what layers you want to create and be very explicit about it.
Okay, so the question in my head there, just when you mentioned Rust up, right, is there a decision that has to be made there, or is this not a decision? Do I put Rust up and cargo in the builder image, or is that something I should be doing specifically as part of the build step within the build pack?
That comes to the heart of like a lot of the kind of architecture of like how you want to design your build pack setup. So it kind of depends as both an organization or how you kind of want it to work. So one of the things we haven't gotten into yet on the platform operator side is one of the advantages of we call it putting it below the seam. So one of the things from all the standardization is that we know where the base image ends and your app starts layer wise. We store that. If you actually, you have the image, right, in Docker? Like if you run pack image inspect, or pack inspect maybe, whatever the image that you built from before.
Oh,
it might just be pack inspect without the image. Yeah. There's metadata that we store as labels on the image, and so we know. So you can see here like the top layer. So that's where the seam is. So we know where the basically base image ends and your app starts. And so that allows us to basically do a thing we call rebase. And so if you're using a distro under the hood that basically provides guarantees ABI compatibility, which this is the business that all these kind of enterprise LTS kind of things are in, right? It's like they will only provide updates as long as it doesn't break the image, because if they do, then you're going to have a bad time. And so this allows us to actually change the base image security update wise under the hood. And so like we've had conversations with Google out in the open and other things where they want to be, and it's not just specific to Google. Like there was this conversation from the question you're asking is like, do I want to be able to, through a rebase? So if you go pack rebase --help, you can kind of see the command. But this concept in CNB is essentially what it's going to do. It's going to do a lift and shift. So it's going to take your application layers without touching them and put them on top of a whole new set of base image layers. And so this is a very big, like, Dockerfile does not do this by design, right? Like the moment you update that from line, you're blowing the entire cache when you do an entire rebuild. And so with build packs, we don't do that. And it's an explicit design choice when you want to do that, because if you have that ABI compatibility, the theory is that those layers should just run on top of the new patch, like vuln kind of thing from your Ubuntu or Red Hat, etc., right? And so by pulling things below the seam, it allows you to essentially update those things without having to update the app layers. If now that discussion kind of, I think makes more sense. of like what you want to choose to maintain on the platform operator side versus kind of the application Buildpack authoring side of the house.
Yeah, I guess the take home for me there, with this specific example in mind, is that I would not put Rust up or Cargo in my builder, and I would put that here, just because.
Yes.
Yeah. Okay.
That's probably what I would do, but I think you were asking like a. Maybe you weren't. I thought you were asking like kind of a generic question, but sorry for the kind of side quest.
No, I mean, I answered some more questions in my head, and it kind of led me to my decision there. Like, I kind of understand the divide now about what my builder should be doing, especially when you correlate the fact that you have to have, or you can use the rebase command to be able to just say, all right, take my application and run it here or here or here. Like, it gives me a much better picture of where the responsibilities lie with the builder and of the build pack itself. So
Yeah.
it definitely makes a lot more sense to me. The sad part is I now need to get Rust up into this image, which may or may not work now that I'm thinking about it. So, yeah, I'm curious now. So, I don't know if we're going to be able to make this work, but we can definitely answer a few more questions. So
Yeah.
I have these 3 variables, layer star, mtar, plan path. I need to be able to build my Rust application. So I'm going to do anything that I can from here to be able to do some sort of cargo build to then get my target release. Let's just call it hello world. I can't remember what the thing is right now. I'm assuming what I need to do is to copy this into layers dir. You said it was then my build pack, like so.
Well, no. So layers dir is already pointing to the build, so you don't have to create that.
All right. Okay.
The only thing you have to create then is any directory you want to be a layer. And there is a kind of whole process for, like the layer.toml, essentially. That's the metadata stuff.
And are those layers overlaid on top of each other to give me the final?
Yes.
Exactly. Right. Okay. So I would just stick this into like bin hello world or whatever. And
yeah, like whatever you layer you want to put it in, but layers directory it itself is not a layer thing. Like you need to create a directory to put it in, if that makes sense.
Okay. Yeah,
but I think like it's also potentially common to put these bin kind of artifact things just in the global workspace as well, right? Like you don't need it's up to you if you want to like create a separate layer just for kind of the bin hello world or not, or if you want to just shove it into workspace.
Okay. One other thing you mentioned earlier in regards to the Gradle GDK phase is that do I have control over caching this Rust up so that it only happens once?
Yes.
I do. Okay.
Yeah. So it like let's assume we can get this Rust up. I think there's stuff you can pass to Rust up to install it to specific directories. I'm definitely not super familiar with the Rust up. I feel like CLI, if you will. But
what?
I think that's just help on SH, right?
All right. Okay. We can look at the script if needed. So.
Yeah. Anyways, so the thing that I would probably do here is I would put Rust up in a layer. So I would probably make a Rust up directory inside of layers dir, right?
All right. So. Like so. Does that mean that we want to somehow do like I don't know what it is yet, right? But I mean, Copilot's already jumping in.
Yeah, exactly.
Okay.
And I'm gonna open up a window so I can look at my own project's reference documentation. And so like we're also gonna want to create for creating a layer. We're going to want to set the metadata on it because I think we want this to be a build layer. We don't want this in the final launch image, correct?
Correct.
Also just trying to find where we document this. Okay. Okay, so in the layers directory, whatever you call the name of the layer, in this case it would be rustup, you write a rustup.toml file. And for reference, can I send you a thing in this?
Yeah, it does private chat. Sorry, I was too busy typing. You can stick it into the group private chat. Excuse me.
Okay. It's not secret, so happy to share with other folks, but this is just on the documentation page. This is the improving performance with caching, which I think is essentially what you're asking me for.
All right. Okay. So we add this, and we can specify whether it goes into the launch or not, the launch image or not. Or
yeah. So there's one more flag that it doesn't, because by default we assume false. But in this case, I think we basically want to flip the bits here. So there's cache, launch, and build. And I think what we want is we want build true, launch false, and cache true, right?
Got it.
And so build is kind of a weird thing in that and maybe we don't actually want build, but build essentially allows you to expose this to other buildpack layers. So actually maybe you don't care about build. Yeah, that's essentially what these three flags are for.
Okay. So, I mean, I'm just going to say, I mean, I don't think this is correct at all. I do expect that to fail completely. Because I'm in this is the massive rustup installer, which I've never looked into before, but it doesn't appear to be an installed dir flag, and I also can't see how to modify where it gets installed to. So we could try this one more time. Oh, I mean, I downloaded it. What am I doing? So I can always just run -- help, and we've got host, toolchain, profile, component, targets, but there's no path, so it seems to just do its own thing, which is not ideal. So I guess our other option would be, because we're using a builder, we could take a look at the Heroku builder, do a container run rmit Heroku builder 24, see if it's got bash, which it does, see what it's based on. It's apt, so we could probably apt update install. So while this is very, very useful, and maybe we still do this, I don't know, could I just do apt update and apt install cargo?
You cannot, in the sense that, remember when I was talking about that it doesn't, you don't run as root. So the reason you can't do that is because if you're able to do that, it would totally break the ability to rebase, if that makes sense, right? Okay. Like you're essentially modifying layers. Like the reason we're able to rebase safely is because we know that the stuff happening at the app and up is not intersecting with anything below it, right?
Okay, let's just try it with the curl approach and see what happens. So I have a build pack now with a detect and a build that I don't expect to work. We have a buildpack.toml. Yeah, I don't think we need anything else here. So I'm assuming if I do I have to build the build pack image, or do I just use it as it is in that directory?
Since it's bash, I don't think you have to package it up, and you can just...
All right. One of the things I am going to do, so we don't run into any weird issues, is create a Rust app directory with a new cargo in it. I'll then do a pack build builder Heroku builder 24 build pack back
And
up
then
a
you hit
directory,
yeah.
which is my Rawkode build pack, and I've forgotten my image name, right? So
Yeah, you need to image name.
we'll just call this YOLO because I have no idea what I'm doing now. But it's fun. I'm enjoying it. So. All right. So it detected. It's now doing a rust up installer. We need a non-interactive environment just to -y that.
I think there's a --desdir directory or a flag that you can use. I'm
Wonder why it
sure
doesn't show you that here.
Because you have to troll through the bowels of the script.
Okay, so
I'm like reading through because Paketo actually has Rust build pack, right? So like they clearly have gone through this themselves.
Is it -dir or -dir?
It's --desdir as one word.
And no modify. All right, Copilot is proven very useful here. Okay, so when I started typing dest, it said, okay, you want -dir to the layer with a no modify path. So we won't try this much longer. We are approaching the last kind of 5 minutes of our session, and I don't want to keep you late, but let's see what we can do.
It's been fun.
Yeah, definitely. -y failed. Is this not the right syntax?
I mean, you could just be less cute, I guess, and write to file and execute it if you want.
Yeah, you're right. That's a much better approach. So rustup.sh.
I mean, I don't know if it's a better approach. It's the fastest approach.
All right.
Yeah. So it's, not that it's important for this, but to note, like, what you did in there is like you are going to write rustup.sh in the current working directory, which will be the workspace directory. And probably if you're doing this for real, you would like write to the temp directory or something, right?
It really doesn't like that -y. Oh, because it. No.
Yeah, because I don't think you need the -- anymore, right? Or you do. Do you?
I swear I've written bash scripts before, I promise. It really, really hates that. Oh no, -dir is not found now. All right.
Maybe they've updated it where they don't accept it, but it looks like it used to work.
All right. Dest. Dir. No, there's no -dir. All right, let's just fake it till we make it, right? I mean, we know what we're trying to do here. We're not going to be able to make that work. Let's just assume I do cat EOF. Let's write this to our layers dir rust up, and I'll just call this go, which is very weird, but echo hello from buildpack. I guess I should give it a shebang, like so. So let's just pretend that's my compiled binary. Normally you would install Rust using Rust up, but we don't know how to augment where that goes to. And I just want to see something build. I knew picking Rust was a stupid idea.
It's not stupid. It's just probably more time than we would have thought.
Exactly. Time is not on our side on our live stream. All right, so we successfully used the Heroku builder, my build pack. We got an image. I'm just going to go inside this image. We won't do anything else. YOLO bash. And we have the workspace directory, which has our application. And you said we'd have layers. Oh, so this didn't make it to the end because I wrote it with launch
Exactly.
false. Right. Okay. So let's change that
So it's
and build
working
it
as
again.
intended.
Yeah, exactly. Good.
I find the launch thing actually really powerful for a lot of people because it allows you to kind of circumvent the need for like a multi-stage Docker file.
So where would that have gone then? So I turned, well, launch and build true collide, or is that okay?
No, they don't collide.
Okay.
Oh, no. So you need to write that. You need to take out the first rust up in that cat on line 4. You want to do that at the layers directory level. And you want the rust up at the layers directory level and not, yeah.
Right. Okay, so this is a layer manifest, and this is the layer itself.
Yes, exactly.
All right, so how do I tell it that if I run my image to run this Go binary?
Okay, so if you go back to that link I sent you, is documented in the text below. It will talk about setting a default start command, number 4. So, and the layers directory, you want to launch .toml, and then here, essentially what it does is you specify the type. So you can have multiple process types, kind of similar to kind of Heroku. And I don't, yeah.
So does it know where to find, sorry, I'm jumping around. How does it know where to find that Go? Is that just because my launch layer, it knows to use that?
You need it won't know where to go unless you add it to the path, most likely.
So can I just do layers?
But you could probably, if you put it in rust up bin go, I think it automatically gets added to the path.
All right, let's try that and see what happens. So. You're doubting me. I can hear it in your voice. You're like, no, David, that's not how it works.
Yeah, I don't think this is how this works.
Incompatible. Destination has to be a string. Processes command should be a string. Okay, I'll make it a string.
Oh, is it? I think. Let me
go. Okay, so now that I've got a launch, I'm assuming that's my entry point overridden.
Yes. I think one of the differences is that it's using a different buildpack API, where we change that between string and array.
Oh, okay.
So if you change the buildpack API to 0.10.
I mean, I'm okay. This worked. So the only problem we had is that I set the launch to be this, but the buildpack name is actually part of this.
Yes.
Rawkode rust up buildpack. So that would have worked, but anyway, I just ran in and ran a file. We got hello. So we'll pretend that rust up worked. We stuck it into a cached layer. We compiled our application, and we got a working Rust image. I will put a link in the description below for anyone watching this after the fact with a link to the Paketo Rust one, so that you don't have to, use anything that I have typed in this session whatsoever, because I made it up as we were going along. However, I think what we've done is showing how buildpacks are cool. We can take arbitrary applications, we can make images out of them. We've hopefully given people enough of an understanding. Hold on, let me go back to our faces. Hopefully given people an understand of the hierarchy of concerns here, right? We've got builders, the buildpack itself is just 2 very simple scripts that allows you to detect when to use the buildpack and do the actual build. There's stuff that we didn't even get into in a lot of detail, right? But you also mentioned that we can compose these buildpacks together, which is a very cool primitive and one that I definitely want to be exploring as we progress or do more sessions on buildpacks hopefully later. And yeah, then you get a production image you can ship. And you can even go a step further to rebase this on new LTS versions of your operating system, as long as there's API compatibility guarantees. I think we covered quite a lot, and we've still got a whole 20 seconds left. So, not too bad, right?
Yeah. Yeah, I mean, I'm sure there's a whole 90-minute session that is building your build pack.
All right. Well, I mean, I really appreciate your time. I don't want to keep you too much longer, but maybe if you could just spend, 10 to 30 seconds saying, it's obviously a very mature project. You're looking for graduation. It's got some big labels on the adopters list. What's next for Buildpacks? Is it just keeping it stable, or is there new things coming down the pipe?
Yeah, I mean, stability for sure is the first and foremost thing, because we have people using this in production, right? I think, we have an RFCs repo, so a lot of the kind of ideas go through there. And the big thing I think we've been working on recently is all this stuff has been really built towards building production images. And we recently just got an RFC merged in, called it the exec-m, which is execution environment, essentially. So the ability for Buildpack authors to essentially have the ability to know the intent of when you're running a pack build, like, am I running this for a dev environment or a test environment? And should Buildpacks, essentially allowing Buildpacks to kind of change their behavior to produce a test image or a development image instead.
Awesome. All right. And I'm assuming the project is open to contributions. So anyone watching this who does want to get involved, you can go to github.com/buildpacks. Feel free to look at their issues, look at the RFCs, and get involved. Terence, thank you so much for your time. It's been wonderful working through this project, and thank you for sharing your knowledge. Any final words before we say goodbye?
No, just thanks for having me on. It's always fun. Always happy to come back, talk more about Buildpacks. If you want to kind of reach out to us, not just via GitHub, we're in the Buildpacks Slack channel on the CNCF Slack.
Awesome. All right. To everyone watching, thank you so much for your time, and we'll see you all next time. Have a great day.